So talking about decentralization, that's actually currently an ongoing situation in my garden as a big storm is hitting the Netherlands. Basically, all my stuff in my garden got decentralized. So I needed to run outside for a bit to grab all the stuff and put it back into one place. So I hope everyone is okay. So I'm Stefan Wiele. I'm a senior program manager with Microsoft. And today we're going to talk about decentralized identity. One thing before we're going to go into the decentralized part, I thought it would be good to show a little bit of the differences between what is centralized and what is decentralized, right? And I think most of you know what centralized identity is and using it on a day-to-day basis. And of course, as the name already give it away, decentralized or centralized basically means we have one central component. And I think the important piece, if you think about identity and think about things like authentication and authorization, the big thing that's underneath there always is trust. So how do we establish trust? That's the big question. And if we look into a centralized environment, it's a pretty easy setup. We have one central entity, which we call the identity provider. We have, in this case, two participants. They set up a trust, which can be in multiple ways. Normally, it will be using certificates or something like that. And then the other participant will trust the same identity provider, which means that in this case, A and B trust the same central entity. So if that central entity is going to tell you that B is really B and A is really A, because we both trust them, we believe that that's true. And then other participants can join. And if you look at this setup, some example protocols that you maybe heard of or seen or that are using a centralized model are OpenID Connect, SAML, WSFED. There are more of them, which you can see as a centralized protocol. The huge challenge you have with a centralized setup is that actually the centralized piece, right? If you look into a more data spaces type of setup where you want people to participate, you don't want to have one person setting up a central store and basically be in control of all the trust that is there. It would basically means that you're in a room and you will appoint one person, and that person, everyone trusts that that person will tell the truth and will tell you, oh, that participant A is participant A and participant B is participant B. And of course, there are also some infrastructure-based things that are challenges here, right? Who's going to host it? Who's going to pay for it? Who's going to maintain it? Who's going to make sure it's secure? Let's walk you through just a very high overflow of how centralized identity would work. So we have that identity provider, also shortened as IDP. We have participant A and we have participant B that has a resource that participant A wants to access. So participant A will navigate to participant B resource. Participant A will authenticate at the central identity provider. So it will establish that trust and say, look, I'm participant A, and that can become, I have a username and password that match up. I have a certificate. I have something else that I can prove to that central entity. That central entity will then issue a token to participant A, which is just a cookie, a document, something like that, something that can be transferred. It's also called a bearer token. Who has the token is able to authenticate. Then participant A will go back to participant B's resource and will give the token. And because the token is issued by that central identity provider, and both participant B and participant A will trust that identity provider and everything it does, there's a trust established here. Because this one is signed by that identity provider, we can check, and then participant A will get access to the resource. Very simple, high over identity authentication. And you can basically apply this whole thing to all the protocols I mentioned before in a centralized setup. But then let's have a look into decentralized. And why are we looking into decentralized? So I already gave a few examples. We don't want we don't want people to basically be in control of that single thing. We want people to join. We want to establish that trust, because that's the key thing where it's about. And if you look into a decentralized setup, we also have that participant A and participant B. But instead of a centralized thing, we have a distributed type of infrastructure. And that distributed infrastructure that is being trusted by both parties. And on that decentralized infrastructure, we can put things and we can look up things and we can get that trust. So if we look into that same type of scenario where we have participant A, participant B has a resource, basically very high over in a decentralized setup, participant A will put their identifier on the distributed infrastructure. Then participant A will never get to participant B resource. Participant B will look up, participant A, I see a typo here, on the distributed infrastructure. It will verify participant A because it trusts that the data on that infrastructure can be trusted. And then it will give access to the resource. There's a reason I call the infrastructure, the layer underneath, distributed infrastructure and not blockchain. Because that distributed infrastructure can actually be anything else. It can be a current distributed infrastructure. Of course, it can be blockchain. It can be multiple things. And there's a reason why I'm putting this out, and we will come to that in a bit. So I talked about that identifier that we put on that distributed infrastructure. Let's have a look at that identifier from a distributed identity perspective. So if you look at that identifier, it has a few specific components. First of all, it will tell you that it is a decentralized identifier. Then it will talk about something called a decentralized identifier method. And then we have a DID method specific identifier. So this is basically a unique identifier for this specific method that person is using. And the concept of a DID method is very important, especially if we look at that distributed infrastructure and what it is. So let's dive a little bit into that the DID method. So currently there are over 80 different methods that are registered, and basically anyone can come up with a specific method and can write something about it and then get it approved, or not really approved, but get it out there as a specific DID method. And if you look at the list here, I only took a few screenshots. I didn't want to screenshot the whole list, but if you want to have a look, there's the DID specific registry, and I can put the link in the IM later, so you can have a look at all the different methods. But those infrastructures are actually defined by that method. So for example, you see some IPFS, which is a specific protocol for distributed systems. Bitcoin is there, Ethereum is there, but there are also other systems in there. So think about web servers or DNS that can be used as a DID method. And this method specifies how to read and write that specific identifier. So if you look at the standards, there are multiple standards here. The first is the core decentralized identifier standard. And the only thing it does is basically defines how such a document should look. And then the other pieces there are the specific methods, which don't talk about the document itself, but talk about how to read it, how to write it, and how to put it on that specific infrastructure that is part of that method. So let's have a look at the decentralized identifier, because now we know we have a decentralized identifier. We know that there are different ways of putting it on an infrastructure, and that the key to the trust is that infrastructure that you put it on. So the components that are there in that identifier are, first of all, a self-description for this distributed identifier, basically indicating like, what is it? Who is this for? Then we can have a set of public keys for verification and a set of authentication methods for authentication. And then we can put in some service endpoints. And all of those things, those are colored out here. We're going to talk about how we see those components match in, and then later on we're going to put them all together. There's a timestamp on it, and there's a signature for integrity in that. This document itself is not going to help you with doing authentication or verification or authorization of specific components. It's only a method to get that trust, right? And to put that on a specific distributed infrastructure. If we want to have that scenario where as a participant A, I want to get that participant B resource, I need to provide something of a proof. And that proof, that can be multiple things. But what we see in the industry and worldwide is that the W3C verifiable credential piece is kind of becoming a big thing. And yes, there are others out there, but still, if you look at there was a research a few months ago by the Dutch government, and they looked into the different type of wallets that are available. And they saw that 80% of those wallets were looking those verifiable credentials. So a lot of people also, when you talk about verifiable credentials, they start to think about certificates and certificate management in general. I think the biggest difference here that you need to keep in mind is that this will take out that central component if you also look after the issuance and revocation of certificates at some point. So how does a verifiable credential work? We have an issuer and a verifier, which could be two different participants, but could also be the same. You can be an issuer and a verifier as well at the same point. And then you have the holder of that specific document. So what will happen is that an issuer can issue a verifiable credential to the holder, and the holder will be the only one having that specific verifiable credential. Then if they go to the verifier, they can present that credential, and the verifier can look at it and can get the data from it. To give you an example here from a Microsoft perspective, if the issuer would be Microsoft and the verifiable credential would tell someone that I'm a Microsoft employee, I can, with that certificate, go to our company store and say, look, I'm a Microsoft FTE, and I'm probably going to get a discount. And the verifier can read and can verify the document. So it will look up the key, what it's signed with, on that verifiable data registry, which is that distributed infrastructure. We can be multiple things, right? So if we put those things, if we put all those things together, you will see we have that DID, which is, this is the DID. We choose what type of method we want to use, and this indicates where the DID is stored and how to read and write the DID document. And then, of course, we have an identifier because we want to look up a specific DID document. So what will happen is that when I receive this DID identifier, I know that's a DID. I know where to look, and I know what to look for. So I can locate that DID document. And then when I get that DID document, I can read that DID document. I can get information out of it. So one of the things here is that we have that set of alt methods and that set of public keys. And those keys I can get out of that document from that trusted infrastructure to verify the signature of that verifiable credential. And so this is all put on that distributed infrastructure. And this is basically how that all maps together. And this is something that is for every specific DID method. So if you're going to put it on a blockchain, or if you're going to put it on something else, it's still the same process, right? It's looking up what's the method, figuring out how to read it, look for a specific identifier, get the document, and get the signature for the verifiable credential. Of course, I can get more information out of that document, right? I can look at the self-description. I can also look for some service endpoints, which will become handy when we're going to talk later on about how this would work in a more in a setup without a person in place. Because if we look at that verifiable credential piece, you have a holder, which in many cases is a person that holds a wallet to store that verifiable credential. But what if we're going to talk about connector-to-connector type of communication? We will come to that in a bit. So one thing we noticed when talking about distributed identities and the different methods is that, of course, there are a lot of pros and cons against multiple DID methods. But the one thing that most of the people are looking for is, how can I do distributed identities? And how can I do it in a very simple way? Maybe to start with and to convert later on to something else. But which type of method would be helpful there? So from the Eclipse Dataspace Connector project, we looked into that, and we came to the conclusion, after comparing a lot of those methods, that didweb is one of those very easy to implement distributed setups. And if you look at didweb, and this is also why it's so important to remember that the distributed infrastructure can be anything. Because with didweb, we are bootstrapping that trust using a web domain's existing reputation. So two things here in place, it's DNS and it's a current web server. So it's all based on current infrastructure, which makes it very easy to implement. And yes, there are definitely some pros and cons. There are some things you need to think about, which those current protocols implement, and I will talk about that a little bit later. So didweb, if we take back like how to look it up. So if we look into the specification of didweb, how does it work? So as I said, we have did as an identifier. Then we have the method, which in this case is web. And then we have the identifier. And in this case, an identifier is basically a domain. And how we bootstrap that trust is to check to see if this domain is actually registered to the person that it says it's registered to. After we're doing that, we know based on the specifications that there's a well-known endpoint where I can find a DID document. And that DID document, that contains the keys and information, which basically means at this point to implement this, and it has been implemented in the Eclipse Dataspace Connector. The only things I think I need is looking up a URL and then getting data from that URL, which is just basic, like getting a document off a web server, and then expect that document and use that to verify and bootstrap the trust. Of course, what I said, there are some considerations here, and they're also in the didweb specifications. First of all, the didweb specification is a draft, and I think I saw some comment coming by as well. There's a lot of draft specifications here as we basically looking and working with very cutting edge technology. And on one hand, the positive thing about that is that there's a lot of things that we could add to these type of standards to remove some of the limitations or security considerations. If you look at the security considerations currently in didweb, one of them is, of course, DNS security. So one of the recommendations in the document would be DNS over HTTPS. You can also thinking about signing DNS records. There are some other things here around DNS. And yes, there are other like methods to hijack DNS and these type of things that we definitely thought of. But in the end, what we're looking at here is how can we find an easy way, which is easy to implement, to start with decentralized identities, and then we can see how we can move on to other, maybe more harder to implement type of methods. And then we have something, and this is more from a connector perspective, where we have been looking at is optional path and did control. And basically what it's saying is that you have a domain name, but you can also have a folder on that domain which hosts another did document. So that means, for example, if I have multiple sets of connectors that have different DIDs, but I have one domain name, I want to put them probably in a subfolder. So I can, me as a company, I'm the owner of the domain, so people can get that DID document. But currently in the documentation, it's basically saying it's a delegation model, which makes sense in a human scenario, but from where we're looking at, it's a different way. It means that if it's in this scenario, for example, .com, they delegated the control of the DID to this specific person. Where maybe in the case of multiple sets of connectors within a company, you wanna, as a company, be in control of what's in those subfolders. So this is one of the things that we're looking at also together with the writers of the specs to see how can this better fit the scenario that we're after at this point. So if we're putting it all together from a user perspective, you would see that participant A will write their DID on the distributed infrastructure, which basically means with didweb is that I create a JSON formatted document and I will put it on a web server, and that's kind of it. Then I can issue a verifiable credential, which is signed with a key that is also published in the document, and issue that to the holder. And a verifiable credential can hold multiple things. It can say you're part of participant A, but it could also say like I'm a member of Gaia-X. It could say I'm located in Germany, and that can also be signed again by different parties that attest that you are actually located there. So the holder will hold those verifiable credentials and can then, when asked, show it to another participant. And there are multiple ways of showing this. A verifiable credential, you can show the credential itself, which contains all the attributes that are in there. But maybe sometimes you want to limit the visibility you want to give to the other participants on what attributes you want to share, what data you want to share. And that is called a verifiable presentation. I can get data from multiple verifiable credentials or limited data from a verifiable credential and decide to share that verifiable presentation with only that limited data. So, for example, if you need to share your age, there can be a claim that's saying, yes, I'm 18 plus, but it's not going to share my birth date because I don't want to share that. Participant B will get the verifiable credential. We'll look into the distributed infrastructure for this specific DID because as part of the verifiable credential, there's an identifier where to find the DID. It will get the distributed identifier. It will read the public key from it, and then it will verify the credential if this information is true. This is all pretty nice if you are a holder, a person that has a wallet where you put the stuff in. But if you want to do it in a more automated way, and even as a participant, if you have more data that probably another participant want to check. So for example, I want to set up a data stream between participant A and B, but before B is going to allow that, they want to know that if the data that they're getting flowing back to participant A is staying in the EU, they maybe want to ask participant A, hey, do you have any proof that this data will stay in the EU? That could be a verifiable credential, but you don't want to, especially in big enterprises, put phone calls back and forth or continuously like asking for that type of information. You want to automate that, but in a secure and provable way. And this is where we're introducing the concept, or not actually this is part of DIF, the Distributed Identity Foundation, which is also a draft standard, is the Identity Hub. And the Identity Hub will actually play a role in this piece of automation and also provide a secure storage for data that you don't want to share publicly, but is maybe needed in some type of relationships. So let's take those same participants, participant A and participant B. But now let's give them both a Identity Hub. And an Identity Hub, you can see that is kind of a database, which is more structured like a distributed infrastructure. So it can contain DID documents, it can do replication, there could be permission, and there's a standard endpoint where others can talk to. So one thing I mentioned when we're talking about DID, there's an option there to put a service endpoint. So participant A will look up participant B on the distributed infrastructure. And as part of the DID document, there's a service endpoint which indicates where to find participant B's Identity Hub. But one thing we don't want to do is participant A to query all the data in the Identity Hub, because we want to stay in control of what's there. The same with the verifiable presentation. We maybe only want to share a limited set of data. So participant A will will go to the Identity Hub of participant B and will put in a request for specific data. I want to know if you're located in the EU. Then participant E will look up, participant B will look up participant A on the distributed infrastructure, which means that I can verify, I can get that public key, and I can see like, are you really participant A that's requesting this data? And I can also see like, what type of data are you requesting? Now, everything's looking good. You're actually participant A, the data you want to get, I'm okay with sharing that, or maybe I want to limit it, and I'm going to put in an approval into the Identity Hub. And this full process can be completely automated of doing so. After the approval has been done, because I looked up participant A, I also know where participant A's Identity Hub endpoint is. So instead of sending it directly, I will send it to the hub of identity, the hub of participant A, and I will put the data there for participant A to verify. And also with this centralized setup of that verifiable data in an Identity Hub, basically means that if I have 150 plus connectors deployed, all of them probably want to look into and want to get some data or store data in there. And that is why that Identity Hub can be a central component. One thing I want to point out here is as well is that identity hub is not meant to be like every participant needs to have an identity hub. It depends on the need of the participants. But you can also envision an identity hub, for example, per data space. If you have any data space specific data that you don't want to put into a distributed infrastructure, but want to make available for other data spaces, that's where you can choose to say, okay, we're going to have that centralized identity hub. It's pretty flexible in that. So if we're putting this all together with the previous picture, the issuer will generate a DID, and in this case, we're talking about didweb, and put it on the infrastructure, which means I put it on a web server. And then it will store verifiable credentials in their hub. So this identity hub is part of this issuer side. Then the verifier will query the will put in a request and saying like I need that information. The verifier will look up the DID of the issuer and will check if everything's okay. And this is how we can get this information. Very simplified version. Then if we're looking into what we currently support with the Eclipse Dataspace Connector. So first of all, the concept that I just mentioned as an idea of an identity hub is part of what we have in the EDC. And then if you look at the different protocols, so we're starting with the centralized protocol, and this is basically how we started 1.5 years ago, I think. And this is also the cool thing, if you think back about what Jim was talking about in the previous session, is the extensibility of the Eclipse Dataspace Connector, which means that if a specific protocol is not supported currently, you can just make an extension, add it to it, and now you can support that specific protocol. I saw one question in the chat about verifiable credentials. I haven't actually put that on the slide, but yes, verifiable credentials is implemented in the Eclipse Dataspace Connector. From a centralized point, we have the OAuth2 client credential flow, and this is also to have backward compatibility or even hybrid mode for people who working with a centralized system. And because of the nature of the Eclipse Dataspace Connector and the standardization, there's basically can be a conversion going on between the different protocols. So I can connect someone using a centralized protocol, or I can use, next to that, I can use decentralized protocols as well. And if we're looking at a decentralized piece, what we have implemented is didweb, where I just talked about. We also implemented didion, and those are running as separate resolvers. So, and based on the identifier, if we're thinking back about the DID, the second piece is the identifier. We know where to look and where to get the data. And of course, you're always free, and it's always possible to add different extension to the Eclipse Dataspace Connector. So I went a bit crazy here and said like SAML, WSVET, Cabros, maybe if you need it. I wouldn't recommend doing that over the internet, but still, if that's a requirement, it could be an extension. And then from a DID perspective, we're not bound to these two that we have here. Theoretically, any of those 80 methods could be implemented as an extension in the Eclipse Dataspace Connector. So if you fancy a specific different DID method, or maybe thought of created your own, that could definitely be part of the Eclipse Dataspace Connector. Okay, I was asked to leave some time for questions. I see I got 15 minutes for questions, but I saw some stuff popping up in the chat as well. So Marcus, do you want to, I'm not sure if you kept track of the questions, otherwise I can scroll up a bit. But
those would be fine for me. So if you already saw some of the questions, feel free to answer.
Yeah, I saw a question by Martin. Is it the same thing like pod in solid? I'm not familiar with pod in solid, so maybe someone else is, and we can check and I can see what it is. And I think that was about the identity hub, to be honest. But
yeah, so to the question with pods in solid, there was already an answer by Peter.
Okay.
But so like you said, so there was another question by David raised. So he's a little bit confused when sending data to why sending data to an identity hub rather than to a connector. Did you mean credentials? It was referred to slide 20.
Okay. So with data, let me do this one. I see we can better use this one. And with
this one, yeah.
Yeah, exactly. Yeah, with this one, what you're doing. So first of all, Identity Hub right now is part of the Eclipse Dataspace Connector, but could be run as a separate entity. And I try to simplify this a bit by skipping the whole authentication process you're doing here. So basically, the first thing that participant A will do with participant B is authenticating, which could be using a verifiable credential to that Identity Hub. And after that, they will request for data. And what I mean with data is that this Identity Hub can contain all kinds of verifiable credential, which will give information about participant B. So for example, one of them could be I'm in Europe, or I'm a Gaia-X participant, or I'm a Catena-X participant, could be a verifiable credential. So that would be as part of the data. It would do the authentication and then request for this specific piece of information, where the participant B can then approve it and send it to the other Identity Hub. So the Identity Hub is, and this is different with the Eclipse Dataspace Connector, where it's an actual storage. It's a database for information that you probably don't want to put on in a distributed infrastructure, but only want to make available to specific people. Like I'm a Gaia-X member. Maybe you don't want to put that out there on the distributed infrastructure, or where you are located, or where your data is located. Yeah. So it's a secure store for those type of credentials.
But very much identity-related data, like you say, the metadata,
yep.
and not the ultimate data set.
No. Oh yeah,
that's where I was confused. You may want to.
I see. Yeah, no, definitely. So no, it's not the data set itself. It's authentic or authorization related data. What's in there? So it's not the data set itself that's in there. It's all around identity.
To be clear. Thanks.
Yeah. Thanks, David. Okay.
And then maybe related to federation, could a participant A or B also federate their identity to somebody else running an Identity Hub, right? Because that's what you do with identity federation, like social login.
Yeah. So So as part of your DID document, you can have multiple service endpoints. So it basically the endpoint is just saying where to find that Identity Hub that contains data related to this participant. So as I say, you could theoretically also have an Identity Hub specific for the data space and then publish that in your document. So you would have your own Identity Hub and an Identity Hub which contains claims or authorization information around this specific data space. So did that answer your question?
Yeah, it's a journey.
It is definitely. And no.
Thanks.
Yeah, you're welcome. And feel free. I have a slide with links, which I can also put in the IM, where you also can find more information about the Identity Hub. And what I said, as this is kind of new type of information, it can take some time to wrap your head around it, where all the different components step in. Marcus, is there a next question?
Yeah, so I don't see any more in the chat, to be honest, but so there's something I would like to address. So you mentioned that DID is and also the Identity Hub, that these are draft standards, right?
Yeah.
So can you elaborate a little bit on the status and what's the future process is for these kind of drafts? So where do we stand?
Yeah, if you look at I think W3C, the verifiable credentials is released. On the others, it's basically the working groups behind it are finalizing the details there. But there are pretty mature drafts that are currently out there, also being implemented by other companies. I don't know anything about the timelines. I'm not involved with that, but I do know that we're with most of the drafts. So I think the most immature, to be honest, at this point would be the Identity Hub draft. If you look at the distributed identifiers and the didweb specifications, they're pretty close to 1.0.
Thanks.
So I see a question around, currently there is no possibility to incorporate different DNS records like PRT, URI to include in the didweb document. Do you think there's any standardized process to include those things into didweb? There is also a method which is called didDNS, which is more around those different pointers. So especially for if you're looking for something like that, I would recommend to have a look into didDNS, which is more where you host the information in DNS and not with a separate web server. I saw someone with a hand up. I'm not sure if there was a question that someone wants to speak up. On the next question, Javier, I see, how does it match up with the DAP system? So good that you ask. So when we started, and let's go back to this slide, the DAP system is all based on that OAuth2 client credential flow. So when we started to build this, we looked into the DAP system and we wanted to make sure to be compatible, to also have a migration path going forward. So the whole reason that this flow is in there is that it's matching up with the DAP system. So you should be able to replace your current IDS connector with the Eclipse Dataspace Connector, and from an identity perspective, have the same type of connectivity there. I see Michael said you mentioned internet-facing OAuth2 is not a good option. Why? I actually mentioned internet-facing Kerberos. There are actually proxies to do Kerberos, but maybe I shouldn't say anything. This is more a fun thing I always say about that. But yes, OAuth2 internet-facing, if you have all the security things in place, like encryption, then that's totally fine. I was referring to Kerberos in this case.
Yeah, so maybe then just a comment from my side, because there's from Javier, I think, also the comment in regards to the compatibility to IDS, especially RAM 3.0. Like Gerhard also answered already, and Boris mentioned that in the morning in his keynote as well. So basically IDSA heads towards these decentralized identities. But what the EDC supports is exactly, when we have a look on this slide, different kind of possibilities to match identity technologies. So what is currently working with the IDS concept mentioned in the reference architecture model 3 is basically this OAuth2 credential flow, where we have the centralized DApps providing different attributes that can be used to identify the participants. And in the future, the direction is more into the decentralized ones that is then also addressed within the EDC. You mentioned that, Stefan, it could be also possible to work with hybrid flow of identities. So I think there we are very so like Jim also proposed, very extensible, and many things are possible.
Yeah, and if you look at the identity standards, you can see all kinds of bridging methods that now are being designed as well. So for example, if you look at OpenID Connect, there's a draft out there to basically bridge the centralized protocol to a decentralized protocol. So you can use them next to each other. And Marcus, as you pointed out, because the EDC basically knows like, okay, for this type of authentication I need to look here, and for this type of authentication I need to look there. Basically, in the core, it will all look the same, but you can connect to different systems.
Mm-hmm.
So I see a question from Philip. To what extent can we trust the information in the Identity Hub? Is it only a self-description configured by the participant, or is there some other trustful entity that certifies the information that participant publishes in the Identity Hub? And then, can I fully trust the information is in EU, or would the participant, its Identity Hub, lie to me? Very good question. If you look at the information that can be in an Identity Hub, it could also be a claim being verified by a different by third party. So that means like the claim, am I in the EU? If I would self-issue that, but being outside the EU and sign it myself, then how can the other party like really trust that I'm speaking the truth? So how we envision this is that there can be an external auditor which will audit that this is true. They will issue a verifiable credential or which you can store in the Identity Hub that they sign. And basically, if you look back at the process of how we check that, instead of looking up the participant, we will look up that issuer on the distributed infrastructure to verify that claim. So that third party would also put information on the distributed infrastructure that I can verify. And even with verifiable credentials, you can have multiple layers of verification. So there are multiple people who can sign it. So you can see, okay, this claim has been verified by this external party. They signed it with their key. I can look them up on the distributed infrastructure and then verify if this claim is really being attested by that third party. So that's how we look into that for the Identity Hub. So it's not only self-claimed information, could also be external information stored in there. For example, Gaia-X can issue you a verifiable credential saying you're a member of Gaia-X. You will store that in the Identity Hub and make it available for others to check to see if you're a participant of Gaia-X. I hope that answers the question. See if I missed anything. I don't think so.
Yeah, I'm also checking, but also there's one other question since we have 4 minutes. Yeah, so okay, it's more like a comment, right?
Yeah, that is more about the future development of the IDS connector. Marcus, do you want to take that one? A basic question on the compatibility between EDC and IDS. That the future development will be EDC, so IDS connector does not have to compensate the decentralized identity.
Yeah, so I will refer to the next session. So
okay, good. There you go.
Yeah, so please wait the 4 minutes, and then I will refer to that in the next session.
I see Augusto has his hand up.
Yes, thank you.
Yeah, go ahead.
My question is if is there any exchange of token between connectors, and if yes, how is token structured? If it contains verifiable credentials, if it points to the Identity Hub, something like that.
Yeah, so that is now, so it depends if you have the centralized setup, which is just an OAuth JOT token, which is based on the standard signed. The other thing that could be a verifiable credential being signed by that entity, like doing the authentication piece as well. So yeah, there is a token exchange. Both are in a JOT format, but one of them would be a verifiable credential. The other one could be an OAuth bearer token or OAuth token if it's in a centralized mode.
Thank you.
You're welcome.
Okay. So then I think it's time to thank you again, Stefan, for this great presentation.
Thank you. Thank you everyone for joining.
Also answering the questions. And yeah, also